The National Electrical Code, or NEC, section 680.23 addresses the requirements for wet niche fixtures, specifying that fixtures installed in wet locations must be supplied from a ground fault circuit interrupter, or GFCI, as specified in 210.8A3. The GFCI must be installed in a readily accessible location within the branch circuit. The NEC does not specifically mandate that the entire branch circuit be supplied from a GFCI circuit breaker at the panel. Alternative options are available, including installing a GFCI receptacle and connecting the fixture to the load side of the GFCI receptacle. This method provides GFCI protection to the fixture and any other loads connected to the receptacle. The practice of installing a GFCI receptacle and connecting the fixture to its load side is acceptable according to the NEC. It achieves the same objective as using a GFCI circuit breaker, which is to provide GFCI protection to the fixture. While GFCI receptacles are generally reliable, they can occasionally malfunction. Unlike GFCI circuit breakers, GFCI receptacles may continue to function as outlets even if they are faulty. This situation poses a potential hazard if the GFCI protection is not functioning correctly. For wet niche fixtures, it is generally recommended to use a GFCI circuit breaker at the panel whenever feasible. This approach offers a more reliable and comprehensive level of GFCI protection. In summary, the NEC mandates GFCI protection for wet niche fixtures, but it does not explicitly require the entire branch circuit to be supplied from a GFCI circuit breaker at the panel. The alternative option of installing a GFCI receptacle and connecting the fixture to the load side is acceptable under the NEC. However, it may not provide the same level of reliability as using a GFCI circuit breaker. Let's delve into the specifics of these requirements and recommendations. The primary function of a GFCI is to protect individuals from electrical shock. It does this by monitoring the current flowing in a circuit. If the current going out differs from the current coming back by a small amount, typically 5 mA, the GFCI trips, quickly interrupting the circuit. This rapid interruption prevents electricity from flowing through a person's body, significantly reducing the risk of serious injury or death. Wet niche fixtures, which are commonly found in swimming pools, spas, and fountains, present a particularly high risk of electrical shock. Water is an excellent conductor of electricity, and the presence of water greatly increases the likelihood of electrical current passing through a person's body. Therefore, the NEC mandates GFCI protection for these fixtures to minimize the potential for electrical accidents. Now, let's consider the two main methods of providing GFCI protection for wet niche fixtures. Firstly, using a GFCI circuit breaker at the panel, and secondly, using a GFCI receptacle. A GFCI circuit breaker is installed in the electrical panel and provides GFCI protection for the entire branch circuit. This means that all devices and equipment connected to that circuit are protected. When a ground fault is detected, the circuit breaker trips, shutting off power to the entire circuit. This method offers comprehensive protection, as it safeguards all components connected to the circuit. However, it also means that if a ground fault occurs, the entire circuit will be de-energized, potentially affecting other devices or equipment on the same circuit. A GFCI receptacle, on the other hand, is installed at a specific location, such as near the wet niche fixture. It provides GFCI protection only to devices and equipment connected to its load side terminals. This means that only the wet niche fixture and any other devices plugged into the GFCI receptacle are protected. Devices connected to the line side terminals of the GFCI receptacle are not protected. When a ground fault is detected, the GFCI receptacle trips, interrupting power only to the devices connected to its load side terminals. This method offers more localized protection, minimizing the impact of a ground fault on other circuits. However, it also means that devices connected to the line side of the GFCI receptacle are not protected. The NEC permits the use of either a GFCI circuit breaker or a GFCI receptacle to provide GFCI protection for wet niche fixtures. However, it is generally recommended to use a GFCI circuit breaker at the panel whenever possible. This is because the GFCI circuit breaker offers more comprehensive protection, safeguarding all components connected to the circuit. It also provides a higher level of reliability, as GFCI circuit breakers are typically more robust than GFCI receptacles. While GFCI receptacles are generally reliable, they can occasionally malfunction. In some cases, a GFCI receptacle may continue to function as an outlet even if its GFCI protection is not working properly. This can create a dangerous situation, as people may assume that they are protected from electrical shock when they are not. For this reason, it is important to test GFCI receptacles regularly to ensure that they are functioning correctly. The test button on the GFCI receptacle should be pressed periodically, and the receptacle should trip, interrupting power to the connected devices. If the receptacle does not trip when the test button is pressed, it should be replaced immediately. In addition to providing GFCI protection, it is also important to ensure that wet niche fixtures are properly grounded. Grounding provides a safe path for electrical current to flow in the event of a fault. This helps to prevent electrical shock and minimize the risk of damage to equipment. The NEC requires that all metal parts of wet niche fixtures be grounded. This includes the fixture housing, the metal conduit that supplies power to the fixture, and any other metal components that may come into contact with water. Grounding can be achieved by connecting these metal parts to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be properly installed and maintained to ensure that it provides a reliable path for electrical current to flow. Furthermore, it is important to use the correct type of wiring for wet niche fixtures. The wiring should be suitable for wet locations and should be protected from physical damage. The NEC specifies the types of wiring that are permitted for use in wet locations. These include types UF, use, and TW. The wiring should be installed in a conduit or other protective enclosure to prevent it from being damaged by water or other environmental factors. Additionally, it is important to ensure that all electrical connections are made properly. Loose or corroded connections can create a fire hazard and increase the risk of electrical shock. All electrical connections should be made in accordance with the NEC and should be properly tightened and insulated. When working with electricity, it is always important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes to provide additional protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. In summary, the NEC requires GFCI protection for wet niche fixtures to minimize the risk of electrical shock. While the NEC permits the use of either a GFCI circuit breaker or a GFCI receptacle, it is generally recommended to use a GFCI circuit breaker at the panel whenever possible. Additionally, it is important to ensure that wet niche fixtures are properly grounded, that the correct type of wiring is used, and that all electrical connections are made properly. By following these guidelines, you can help to ensure that wet niche fixtures are installed safely and that people are protected from electrical shock. Let's consider a few more detailed aspects of GFCI protection in relation to wet niche lighting. The selection of the appropriate GFCI device, be it a circuit breaker or a receptacle, is crucial. GFCIs are designed to trip at a specific current threshold, typically 5 mA, as mentioned earlier. This sensitivity is essential for detecting ground faults that could be harmful to humans. It's important to ensure that the GFCI device chosen is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertech, to verify that it meets industry safety standards. The installation location of the GFCI device is another important consideration. The NEC requires that the GFCI be installed in a readily accessible location. This means that it should be easily reachable and not obstructed by furniture, equipment, or other items. This accessibility is crucial for testing and resetting the GFCI in the event of a trip. The location should also be protected from moisture and other environmental factors that could damage the device. When using a GFCI receptacle, it is important to understand the difference between the line-side and the load-side terminals. The line-side terminals are where the power supply from the electrical panel is connected. The load-side terminals are where the wet niche fixture and any other protected devices are connected. It is crucial to connect the wiring correctly to ensure that the GFCI provides protection to the intended devices. Connecting the wiring incorrectly could result in the GFCI not functioning properly, leaving people vulnerable to electrical shock. As previously mentioned, regular testing of GFCI devices is essential to ensure that they are functioning correctly. The test button on the GFCI device should be pressed monthly to simulate a ground fault. When the test button is pressed, the GFCI should trip, interrupting power to the protected devices. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Furthermore, it is important to visually inspect GFCI devices periodically for any signs of damage, such as cracks, discoloration, or loose connections. Any damaged GFCI devices should be replaced immediately. The NEC also addresses the requirements for bonding of metal parts in and around swimming pools, spas, and fountains. Bonding is the process of connecting all metal parts together to create an electrically continuous path. This helps to equalize the electrical potential between different metal parts, reducing the risk of electrical shock. The NEC specifies the types of metal parts that must be bonded, as well as the methods for bonding them. These requirements are intended to create a safe environment for people using these facilities. In addition to GFCI protection and bonding, it is also important to follow other safety practices when working with wet niche lighting. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes to provide additional protection. Avoid working in wet conditions whenever possible. If you must work in wet conditions, be extra careful to avoid contact with water and electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. They have the training and experience to safely install and maintain wet niche lighting systems. Remember that electrical safety is paramount. By following the NEC requirements and recommended practices, you can help to ensure that wet niche lighting systems are installed safely and that people are protected from electrical shock. Now let's delve into specific scenarios and examples to illustrate the application of these principles. Imagine a scenario where a homeowner is installing a new wet niche light in their swimming pool. They have two options. Firstly, they can install a GFCI circuit breaker in the electrical panel to protect the entire branch circuit that feeds the pool light. Secondly, they can install a GFCI receptacle near the pool and connect the pool light to the load side of the receptacle. If the homeowner chooses to install a GFCI circuit breaker, they will need to ensure that the circuit breaker is properly sized for the load of the pool light and any other devices connected to the circuit. They will also need to ensure that the circuit breaker is installed in a readily accessible location and is protected from moisture. If the homeowner chooses to install a GFCI receptacle, they will need to ensure that the receptacle is installed in a weatherproof enclosure and is located at least 10 feet away from the edge of the pool. They will also need to ensure that the pool light is connected to the load side of the receptacle and that any other devices connected to the receptacle are also protected by the GFCI. In another scenario, consider a commercial swimming pool at a hotel. The pool has multiple wet niche lights, as well as other electrical equipment, such as pumps and filters. In this case, it would be more practical to use GFCI circuit breakers to protect the entire branch circuits that feed the pool lights and other equipment. This would provide comprehensive protection for all of the electrical equipment and would minimize the risk of electrical shock to swimmers and staff. The hotel management would also need to implement a regular testing and maintenance program to ensure that the GFCI devices are functioning correctly and that the electrical system is safe. This program should include monthly testing of the GFCI devices, as well as visual inspections of the electrical equipment for any signs of damage. Any damaged equipment should be repaired or replaced immediately. Furthermore, the hotel management should provide training to their staff on electrical safety practices. This training should include information on how to recognize potential electrical hazards, how to respond to electrical emergencies, and how to use electrical equipment safely. By implementing these measures, the hotel management can create a safe environment for their guests and staff. Now, let's discuss some common misconceptions about GFCI protection. One common misconception is that GFCI protection is only necessary for swimming pools and spas. While GFCI protection is particularly important in these locations due to the presence of water, it is also required in other locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. The NEC specifies the locations where GFCI protection is required. Another common misconception is that GFCI protection is a substitute for grounding. GFCI protection and grounding are both important safety measures, but they serve different purposes. GFCI protection protects people from electrical shock by interrupting the circuit when a ground fault is detected. Grounding provides a safe path for electrical current to flow in the event of a fault, helping to prevent electrical shock and minimize the risk of damage to equipment. Both GFCI protection and grounding are necessary to ensure electrical safety. Another misconception is that all GFCI devices are the same. GFCI devices are available in different types and with different features. It is important to choose the appropriate GFCI device for the specific application. For example, some GFCI devices are designed for use in corrosive environments, while others are designed for use in high-voltage applications. It is also important to choose a GFCI device that is listed and labeled by a recognized testing laboratory to ensure that it meets industry safety standards. Finally, it is important to remember that GFCI protection is not foolproof. GFCI devices can malfunction, and they may not always protect people from electrical shock. It is always important to take precautions when working with electricity, even when GFCI protection is provided. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes to provide additional protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. In conclusion, GFCI protection is an essential safety measure for wet niche lighting and other electrical applications. By understanding the NEC requirements and recommended practices, you can help to ensure that electrical systems are installed safely and that people are protected from electrical shock. Remember to choose the appropriate GFCI device, install it in a readily accessible location, test it regularly, and follow other safety practices when working with electricity. By taking these precautions, you can help to create a safe environment for yourself and others. The NEC is updated every 3 years to reflect changes in technology and safety standards. It is important to stay up to date on the latest NEC requirements to ensure that electrical installations are safe and compliant. You can access the NEC online or purchase a copy from a reputable publisher. You can also consult with a qualified electrician to learn more about the NEC requirements and how they apply to your specific situation. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone.